Good morning to all. I am Sneha. Today my seminar topic on problem solving with recursion. Now we are going to discuss about these topics: introduction, recursion, problem solving with recursion, base case, recursive case, program for using recursion to calculate the factorial of a number, and conclusion. Introduction. A problem can be solved with recursion if it can be broken down into smaller problems that are identical in structure to the overall problem. A recursion. A function calls itself to solve a problem. A recursion can be a powerful tool for solving repetitive problems. First of all, we have to know that what is recursion. Simply, we can say a function called itself. Let me see problem solving with recursion. To understand this, for taking a real life example, let's say I want to fill a bucket of water and my function is actually fetching only a cup of water at one time. So I will keep on doing this process or repeating this process again and again until my bucket is full, which will be my base condition that I have to fulfill and fill up the cup and put it into the pocket will be my function. I am calling the function again and again so that my bucket is full of water. Problem solving with recursion. Any problem that can be solved recursively can also be solved with a loop. In fact, recursive algorithms are usually less efficient than iterative algorithms. This is because the process of calling a function requires several actions to be performed by a computer. These actions include allocating memory for parameters and local variables, and storing the address of the program location where controls returns after the function terminates. Means many problems that can be solved using loops. Recursive functions are designed to solve problems by breaking them down into smaller similar subproblems until a base case is reached. These actions, which are sometimes referred to as overhead, take place with each function call. Such overhead is not necessary with a loop. Some repetitive problems, however, are more easily solved with recursion than with a loop. Where a loop might result in faster execution time, the programmer might be able to design a recursive algorithm faster. In general, a recursive function works as follows. Here, in general, recursive function works as follows. If the problem can be solved immediately without recursion, the function handles it directly and returns the solution. If not, the function breaks down the problem into a smaller similar versions and call itself to solve these smaller problems recursively. Yeah, in order to apply this approach, first we identify at least one case in which the problem can be solved with recursion. The two cases: base case, recursive case. Base case, the function first check if the problem can be solved immediately without recursion. If so, it solves the problem directly and returns the result. Means here we can see how it generally works. Base case, it is a condition where the function stops and calling itself and directly provides the solution to the problem. A recursive case, if the problem cannot be solved immediately, the function reduces it to a smaller similar sub-problems and calls itself to solve that sub-problem. This process continues recursively until the base case is reached. Means when the function solves smaller similar subproblems by calling itself until it reaches a stopping condition where the solution is directly returned. Here, let's see, using recursion to calculate the factorial of a number. Mm, Find the factorial 5. This is the initial call to calculate the factorial of 5. Recursive case, 5 factorial equal to 5 into 4 factorial. Here the factorial of 5 is expressed as 5 multiplied by the factorial of 4. This is because the factorial of any number n can be calculated as n multiplied by the factorial of n minus 1. A recursive case, 4 factorial equal to 4 into 3 factorial. Similarly, the factorial of 4 is expressed as 4 multiplied by the factorial of 3. A recursive case Here 3 factorial equal to 3 into 3 factorial equal to 3 into 2 factorial. The factorial of 3 is expressed as 3 multiplied by the factorial of 2. Base case 2 factorial equal to 2 into 1. Finally, the factorial of 2 directly calculated as 2 multiplied by 1. This is the base case where the recursion stops because the factorial of 1 is defined as 1. Here, next example program. This is program uses recursion to calculate factorial of a number. Defining a main function. Inside main function, it prompts the user to enter a non-negative integer. It then calculates the factorial of the entered number using a function called factorial and stores the result. Finally, it prints out the calculated factorial. The factorial function itself is defined below. Main function. It uses recursion to calculate the factorial of its arguments number assuming it's non-negative. If number is 0, it returns 1. Otherwise, it recursively calls itself with number 1 until it reaches the base case. The program calls the main function to start the execution. Here is the program output. Enter a non-negative integer, 4 enter. The factorial of 4 is 24. Conclusion. It is a powerful technique for solving the problems by breaking them down into smaller, more manageable subproblems. However, it is essential to ensure that recursive functions have a base case to prevent infinite recursion. With careful design and understanding, recursion can be a valuable tool for problem solving in Python. Thank you.